Hi, my name is Steve Hanley.
And I'm Rob Parent.
We're part of the NDAC product team here. We're going to show you how to get started in Jupyter Notebook and Jupyter Lab for doing some basic vibration analysis in Python. Let's minimize our big faces, even though they look good, especially Rob's. Okay, here we are. So we're in the Anaconda Navigator. So this is a Windows machine. We're just searching. Where do you even do that? Where do you start typing?
Type it in.
Let's just start typing. Oh, there you go. Anaconda Navigator, so we already opened that. And you'll notice there's Jupyter Notebook and there's Jupyter Lab. We're going to start by opening Jupyter Notebook. This will pull up a browser, I think. Here we go. And this is just in the root folder under your C drive and your whatever user you are. We're going to make a new notebook. What are we going to call this? Intro to Jupyter. All right, so we've already installed our library, the NDAC library, but you can do that in a Jupyter Notebook. You just do pip install NDAC, and this should be already installed, but it will double check. Already satisfied, good. So I'm going to cut that out. I'm going to import the libraries I need, which I know I need NDAC. I know I need pandas to get the data.
Yep.
And I don't know if I noted, we have another video where we did an intro to Colab. So, and in that video, I didn't ever tell people, you can run the cell by clicking this run button here. You can also do shift enter inside of a Jupyter Notebook to run it. You could also run kind of all cells below or all cells above. So whatever you want to do there. All right. We're going to start by importing I'm going to redo this. So in Python, there's a bunch of libraries. We're using these two libraries now, but when we import them, we can assign a variable to them to make it easier to reference that library in the future. Typically with pandas, people import it as PD, so when they use it later, they can just do PD dot instead of pandas dot. So data equals PD.read CSV, and I have this data. Where is the data saved?
Do you want to briefly explain what pandas is or what it's allowing us to do?
Yes. So pandas is mostly used for their data frames, which structure data in an intuitive way, basically as a table. There's a lot of capabilities built into pandas, so you can do all these built-in functions, calculating RMS, max, min. It is really nice and easy to filter for certain segments of time or based upon certain conditions if you have like a database. So for our case, though, it's really nice where you have an index that is one unit, whether it's seconds or date times or whatever, and then the columns are your sensor data that you're going to analyze, and they're treated differently.
Right. Makes sense.
All right, so we got the bearing data. It's in our downloads folder, which I'm going to go get that here under users, parent, desktop, where downloads. All right, so here's the folder. Now I'm going to show something that is annoying in Python the first time you use it, but it's a good thing to highlight. All right, so I have now the file location that I want to read a CSV in. And if I do shift enter, it's not going to like it because there's these backslashes.
Right.
So there's two ways around it. One, you can make these backslashes double backslashes. Oops.
This definitely threw me off.
Yeah. The other way to do it, which I prefer, is just to put an R in front, which I think means like real string or something. And there you go. That's a little easier. Now, when I read the CSV, I didn't specify to treat the first column as the index. So I'm going to do that here. Index call equals 0. And then when I do that, now you see that the time is, it's treated differently basically than the sensor data. By the way, this is all, this data is from a blog, top 12 vibration metrics, I think. Hopefully it comes up in Google. DuckDuckGo, there it is. Rob doesn't trust the man. All right, so this blog, if you want to look a little bit more about where this data is coming from, but that's where it is. There are some bearing data that the University of somebody generated a number of years ago that have different fault conditions in their bearings. Mm-hmm. So there it is. Now I have the data. Okay, not like our head there. What am I going to do next? I need to plot it.
Yeah. Well, you can look at the real time, or you can look at the time series data, or you can just skip right into doing some analysis.
Well, quick look at the time series data. Everyone likes to plot it first thing. So import plotly.express as px. Now I have 120,000 data points. I can plot all of it, which I will for the purposes of this video. In previous videos and in others, we've shown you that there's a function in our library to kind of reduce a large data set to a more manageable number of data points to plot by basically plotting the min to the max. But 120,000 maybe is around the limit that you can handle. So px.line. And I just pass in this data frame, and I will say fig.show. Here we go. And it's going. It might be making our computer a little mad because it's 120,000 points. Here we go. There it is. Nice. Sweet. There it is. Now you'll notice there's a lot of frequency content in here. And so we're engineers. We want to look at this in the frequency domain. And specifically in this video, we're going to do that with the PSD. Mm-hmm. But I should also mention, we said we're going to go through Jupyter Notebook and Jupyter Lab. This is Notebook. It's like our last video. We're going through Google Colab. You have cells, output data beneath it, and you kind of continue. You can make these cells, mark down text.
Yep. What's the major difference between Colab and Jupyter Lab?
Good question, Rob. Let's go see that. We will go into, there's two ways to go into Jupyter Lab. The main difference is basically Jupyter Notebook is this kind of single stream down, if you will. You have to kind of go in this linear fashion, although, yeah. And then Jupyter Lab becomes more like a full-on environment. So you have in one view, so in one tab, you can kind of drag and drop different windows inside of this. There's also some other nice features where you can kind of preview markdown text, and you can kind of have a navigator theme, in real time. Mm-hmm. Jupyter Lab came out after Jupyter Notebook. So in general, if you aren't used to Jupyter Notebook, I'd probably recommend starting in Jupyter Lab.
Or Colab.
Or Colab. All right, so we're going to go into Jupyter Lab here. You can do that by just changing the URL to say lab at the top. The other way to do it would be back at our Anaconda Navigator, which I will pull up in a second to show you the other way to pull this in. So here we go. So I'll close this out. Now I will go into the Anaconda Navigator, launch Jupyter Lab. And again, it's kind of came after, it did come after Jupyter Notebook. It's built on top of Jupyter Notebook, so it's still run in your browser and has a nice environment. So over here has this navigation that our head's in the way. I think, I don't know which one. We'll make our head big for a second. All right, here, the intro to Jupyter is the one we were just using. And so as that's, it's going to take a moment to open because there's 120,000 data points that I plotted, but here we go.
There you go.
Yeah, not too bad. So here it is, and again, I can kind of drag and drop inside of here. It's nice if you have a couple different notebooks and you want to compare. You can, maybe have a text file. I don't know what this is doing. Oh, I think in here I could say endac.calc. Let's see. We're going to do PSDs in a second, so that didn't work. Oh, because this is markdown text. It doesn't like that. Here we go. Maybe if I do this. There's some way to bring up the contextual help. Oh dear. I'm not sure. Well, Oh, I didn't import. Oh, this isn't live. Okay. This is in another, if you remember earlier in the video, I think we were server 8889, now we're 8890, so they're separate. Now this is a contextual help. This is actually helpful if somebody learned. If you just notice, I just ran read CSV. I didn't even need to pull this up. It's showing me all the, the API to use this function. And now it's also showing me some preview of the data. That's pretty cool.
Yeah.
Let me get rid of this. Contextual help is sweet. Okay. I am not going to plot this whole thing again because we've already done that, and I don't want this thing to be slow. I'm going to kill this.
That's a place where Jupyter Lab might be more helpful.
Yeah, this is actually really helpful. And so as you see here, as I'm typing this out, ndac.calc, it's showing me the packages within it, PSD. When I was just typed out PSD, it was showing, this is the entire, this is the raw data. And then when I specify a function, this is the raw data of that function. If I do a question mark, let's see if that works. Yeah, it prints it out here. But now in Jupyter Lab, you don't even need to do that with this contextual help in real time. All right, so we're in Jupyter Lab. We're doing a good job. We know we want a PSD, so I am going to say PSD equals ndac.calc.psd.welch. And I see here the parameters that I can specify. Remember to docs.ndac.com have more stylized documentation. Here you can see calc, PSD, and the different functions within this. So we're using Welch. We're going to pass in the data frame, which is just the variable name data. And we could say df equals, but Python's going to assume the first variable we're passing in is the first one. Yeah. Oh dear. We're going to specify the bin width as 1 hertz, which is the default. So maybe we'll do 2 hertz just to change it up a bit. And that's all we're going to do. And we'll print this out. So here you go. There's a PSD. We'll make a plot of this. First, I'm a stickler for themes, so I'm going to say ndac.plot.utilities.
Yes.
.set theme. Right. And I'm going to choose ndac light. Nice. Okay, and then I'm going to say figure equals px.line. So what's px, Rob? Oh, I don't think I've imported it, so I need to import it. And then you'll know what px. So Plotly Express is a nice, clean as px.
We mention it all the time, but Plotly's great. Makes it lots smoother.
So I'm going to pass in the PSD. I'm also going to say, well, this is, again, my Jupyter Lab is showing me all great things that I need to start using more of, where the contextual help in real time, it's showing me all the parameters for px.line, one of which I'm going to do here is log x equals true and log y equals true. And log y equals true. I'm also going to do update layout. Let's see if will it show me? Let's not show that. This is another way to update. The layout is a Plotly figure object has the data itself, and then a layout component which specifies just how it's styled. The y-axis titles. You can also do crazy things like adding in a watermark, an image that you want overlay the plot. But here I'm just going to do something simple and say x-axis title text equals frequency. How am I doing, Rob? Am I doing anything too confusing yet?
There's a lot to soak in, but people can always, skip back and look at it again. We're trying to throw a lot of valuable information out at once.
Okay.
I think it'll all come together once we see. There we go.
There's a PSD. And that, I'm going to zoom out a tiny bit. It's a little bit better.
Yeah.
I really like how my legend is. I'm going to update my figure to. I'm going to make the legend title text go away. Basically just an empty string.
Mm-hmm.
Here I'm going to get a little crazy, and I'm going to say legend. I think this is right. Orientation equals V. So it's going to be a vertical orientation.
Okay.
No. I'm going to change
You're
this.
going to do that? Is that for...
I'm going to do legend Y equals 1.0. I think this is going to put it on top.
Okay.
Haha!
Oh, nice. Okay.
Sweet.
Sweet.
Okay. So this is a PSD. You can see, well, this is Plotly. There's, clearly some dominant frequencies, but there's also just a lot of broadband content. And this is good. This is real data, and that's what happens in the real world. There's not a distinct frequency tone typically. It's across a large number range. So when people are analyzing vibration data, they typically will do the power spectral density like we just did. And then the next step would be to look at it with log-spaced bins. So we have another function in our library, which will use our sweet Plotly, or sweet contextual help, indac.calc.psd.toOctave. Okay. So in this function, we pass in a data frame that defines our PSD, and we convert it to octave space bins by specifying the start frequency and how many bins per octave. So here we will do that. PSD octave equals PSD f start. We'll start at 10 hertz because this content isn't really that useless below 10 hertz. So we'll start at 10 hertz and we'll do 3 bins per octave.
Sounds good.
Octave bins equals 3. And we'll just print this out as oct. Okay. Good. Now we are going to plot this.
What's that error sign?
Yeah, it doesn't like, when I convert it to octave, there are some of the octave bins were so narrow, all right. When you go to octave spacing, it's basically taking your linearly spaced PSD and it's aggregating the amount of energy in this now wider range. And for some of our ranges, especially the earlier ones, the log spacing was less than 1 hertz. And our input data had 1 hertz spaced bins. So it means that there is 0 content in some of those earlier bins because our linear spaced PSD was spanning beyond them. You get around that by doing a tighter PSD to start instead of a bin width of 1 hertz, doing 0.1 hertz or something like that.
Gotcha.
But I actually don't think we started at 10 hertz anyways here, so that probably happened at like the lower frequencies that we don't care about.
Yep.
Okay. One thing I'm going to do here is, now that I have this this PSD oct as a data frame, you're going to want to, this contextual help is slowing me down, I think. What's happening? Here we go. You may want to save this, which you can do is just to CSV PSD.csv. And that will show up here. Our big head isn't in the way. There. You guys see here. Okay. So that would be nice if people want to get the output of the PSD as a CSV, but we're going to create a new plot here. We're going to do PSD octave. I'm going to get rid of my contextual help right now. Or maybe that wasn't slowing it down. It's just your computer.
Yeah.
Okay. We need to get this guy a new computer. There we go. So I'm going to pass in PSD oct. I'm also going to do this other, change the legend. All right. There's our octave space PSD.
Yeah. A little more useful, maybe.
A little more useful. It's a little small like this, so one thing I want to do is I want to just save this as a standalone figure. And I'm going to do that by saying fig.write.html and octpsd.html. I'll run that. So that saved, I think, if our big head is in the way again. Here it is. I'm going to double click it. And it's opening, I think, in a new tab.
This should make it a little easier to share.
Open the new browser tab.
There we go.
So the nice thing about this is I'm not, well, this is a standalone HTML file that you can send to somebody else. They still can now zoom around inside the browser, isolate certain figures or certain variables, all type of things. You can even output an image from your browser. So, but with that, I think we did a quick introduction to Jupyter Notebook and Jupyter Lab.
Yeah.
If we can do a quick recap, is there anything I missed that's worthwhile of going through here?
I think we just mentioned what we've mentioned in the past videos, which is any, you learn these things. There's only so much we can show you in 20-minute videos. You're going to learn a lot more. Stack Overflow or just Googling what you're trying to do specifically.
Exactly. And this is part of a series here where we showed you how to download Anaconda, which is getting started in Python in the first place, then how you kind of can start writing code in Jupyter Notebook and Jupyter Lab. That was this video we just did. We have another video we'll do in a moment on using Spider, which is more of a MATLAB type environment. We have another video of getting started in Colab, Google Colab, which is basically a Jupyter Notebook, but hosted in the cloud, which has a lot of benefits with the one drawback of you can't save and access data locally like I just did here, where I saved it directly to my desktop. I pulled data directly from my computer.
So whatever works for you, whether you have past MATLAB experience or just like using Google stuff.
Yeah. And there's lots, and we went through a lot of this code here pretty quickly, but there's lots of videos going through more specific tutorials on generating PSDs and frequency analysis and shock analysis, etc., as well as going to docs.indac.com for a bunch more examples and documentation.
Yes.
But with that, have fun, and we'll see you next time.
Yeah. Thanks for watching.
All right. Thanks, everyone. Bye.